Well, hello, and thank you all for joining us today. My name is Greg Johnson with Loring Consulting Engineers. I'm a member of the Illuminating Engineering Society. I'd like to welcome you to our presentation on 2021 International Energy Conservation Code for Commercial Lighting and Controls. We have a great presentation lined up for you today, but before we get started, I'd like to cover a few housekeeping items. So at the bottom of your screen, you'll see a Q&A box where you can feel free to submit questions throughout the presentation. And at the end of the presentation, we'll address as many questions as time permits. And lastly, as a reminder, the presentations are all recorded and archived on our YouTube channel and IES website, and you will be able to view the presentations at a later time or recommend to others. So today, we're happy to welcome Harold Jepson, whose presentation will cover commercial building lighting controls and electrical sections of the 2021 IECC, as well as the applicable sections for additional efficiency, functional testing, and lighting alterations. This presentation introduces the importance of energy efficiency standards and presents the IECC scope for both new construction and building alterations. Using application emphasis, it steps through the major interior lighting control provisions. It highlights the control requirements for exterior lighting, automatic receptacle control, and energy monitoring. Each provision is represented or presented with the core requirements, applicability to specified building and space types, and the key exceptions. Harold Jepson is the Vice President of Standards and Industry Relations for Legrand's Control and Lighting Divisions. As a licensed electrical engineer and well AP, he is a 30-year veteran in the energy, lighting, and building automation industry. He serves on the ASRE IES 90.1 and Standard 100 committees, the IECC Lighting, Power, and Renewable Subgroup, and the IES Lighting Control Systems Committee. He's the technical lead for Legrand's Energy Code Solutions program and a regular presenter on lighting and control energy code topics. So without further delay, I'd like to introduce you to our speaker, Harold Jepson.
All right, well, thanks, Greg. And I complimented your leadership here on the organization that you have. I have a chance to work with and present with a lot of IES chapters. And hello, y'all. I'm from the West, but I love the inclusiveness of that. And so today, as Greg introduced, we're going to talk about the 2021 IECC. And actually, I've got some things to share with you of what I know about what's happening there in North Carolina. So this is a AIA presentation. They always ask us to put up this disclaimer slide. All it indicates is that, you know, by way of this presentation, that they're not endorsing any products or services, and will be agnostic actually to technology. We're going to just stay technically with the energy efficiency code here. But what I will mention is if you have an AIA number, you're actually registered with the AIA, we have to be able to report that to AIA for you. The rest of you, a certificate is usually fine for the self-reporting needs, but we want to make sure those numbers get to us so we can give you the credit for being here today. So we're going to talk through a little bit what's happening in North Carolina, a little introduction and scope of the 2021 IECC. We'll go through the interior lighting control requirements, the exterior lighting, the additional efficiency requirements. There definitely were some changes with that. And then I'll share with you compliance helps. And as far as compliance helps go, you should have inside the chat, if you can get it as a PDF, and of a quick guide that we use, and this course will follow that. If you want to go ahead and grab that and download that, you can follow along with some of these requirements as I go through them. So what's happening in North Carolina? I try to capture what's happening in all of North America, Canada, and the 50 states here. Sometimes it's hard. I'm not in all the markets. But my understanding of what's happening in North Carolina is that you did adopt a 2024 North Carolina State Building Code, which includes your Energy Conservation Code. It's based on the 2021 IECC. That was adopted back in January. Now, adoption is one thing, and effectiveness is a separate thing. It had intended to be effective. My understanding was July is what I knew at the time. And then in March of this past year, your state fire marshal's office are the ones that have responsibility over the building codes. They issued a letter, and there apparently are some other statutes or laws within your state that says certain conditions have to be met first before they can go effective, and then there also has to be a 12-month transition period before it can go effective. And so I did have conversation with that or communicate with that office this week. Apparently, not all the conditions have been met. It is published, so you can go get access to it on IECC. I actually have a QR code at the end of this that you can go see a free view of it. But right now, we're on a 12-month, every single day we move 12 months out until all the conditions have been met. And there's something having to do with organization of a residential council or committee, code council. I guess it has not been done. And I think from what I understand, that's the remaining thing. So what I'm going to share with you, you may already be complying with in other places. You may have projects that are requesting it, but it's not mandated or effective by the state as of yet, and we're at least 12 months from that happening. So hopefully that's helpful for you. I think the one thing to mention about the 2021 IECC is that there is an alternative compliance path, and that's using ASHRAE 90.1 2019 version. I will tell you that this version of the IECC was a big jump in the area of lighting and electrical. It really kind of brought the IECC more on par in that area with ASHRAE 90.1. So this is a chart that I like to show just to say, what is it that we're trying to accomplish? And this is produced by one of our national laboratories for the US Department of Energy. And what it does is, if you see the flat line to the far left in the top, it normalizes essentially the building's energy use, both residential and commercial, back in 1975 as 100 energy units, for the purpose that we can show how good are we doing in terms of being more efficient with buildings over time. That bluish green line is the IECC residential, so that's residential. And the green actually follows ASHRAE. ASHRAE is ASHRAE 90.1 is the national standard. And I want to say ASHRAE IES, it's a joint effort there, is the national standard for commercial buildings. And so if we apply that to the changes that you're seeing, which is actually, you're skipping a code. You've been on the 2015 IECC in North Carolina, and you're going to now jump to the 2021. So you missed one of the code cycles, but it essentially for commercial buildings, it represents about 11.5% reduction in energy use. And you can see that, the next version of ASHRAE is out, and that was a 14% change. So pretty significant coming, but combining those two is about 11.5%. All right. This just is the quick guide, and how this presentation and how I like to use it is that you've got a reference up here in the top left corner on the provisions that I will be speaking about. If there are changes or new requirements, and this only applies to anything that changed from the 2018, I'm sorry, all these dates, the 2018 to the 2021, that's usually highlighted in red in this presentation. So in the quick guide and on this presentation, those things on the left, that will be essentially the provision, what are the requirements we need to follow for it. The center section will be where does that apply, and under what conditions do you have to follow that provision, and the far left side, our right side, will be the key requirements. So what's happening in power and scope of the code in the 2021? No real significant changes from the past. It applies to new construction and additions, alterations to buildings, and takes into account, at least for the lighting and power side, is all of the lighting control and power requirements, both interior and exterior, are applied. One thing that did happen is that multifamily dwelling units, which used to follow the residential standard, That's why there was an exemption for it here. The dwelling units are now under the provision of the commercial part of the code, and I'll show you a requirement for that. As far as buildings that go under alteration, when is it triggered? It is triggered when for lighting and power, or for lighting specifically, I should say, is when we, in any given space, touch 10% or more of the luminaires. We then trigger compliance. So it is a space-by-space requirement in terms of how it's triggered. It's not like if you change one small space, but you're in a fit out that's over 5,000 square feet. It doesn't apply to the whole space, but it is a space-by-space requirement. The other thing that did change here more recently is that functional testing, which was not part of the requirements, when you had to comply under an alteration, have now been brought in. So in terms of that multifamily dwelling unit, what did change with that is that we have efficacy requirements. I know a lot of commercial buildings, right, we're talking about lighting power. What's the lighting power density? But in dwelling units, we have a responsibility to make sure that we are putting efficient lighting in. And the requirement is that 90% of the permanently installed lighting must have a lamp efficacy of at least 65 lumens per watt. So those are largely LED. I think maybe some compact fluorescents can meet this, but those are pretty much a thing of the past. Or if it's a light source that's embedded into a luminaire, it has to at least be 45 lumens per watt. So that's the requirement. No other control requirements in dwelling units. And then sleeping units. So you think about, if we look inside the code, there's like a dormitory or a fire station, sleeping quarters, places like that, those other places that would be considered sleeping units. You can follow that same requirement for efficacy, or there actually are some lighting power requirements in the space-by-space tables for some of those spaces. And there's a question here, do hotel guest rooms fall under this? They do fall under that. But what is different is that there are also control requirements for sleeping units under the special application control that apply to hotels and motels. And I'll cover those as we get down to there. But yes, they have efficacy requirements or interior lighting power. You choose what you want to use for sleeping unit spaces. And then there are these control requirements that will apply on sleeping units. All right, let's take a look at the interior lighting controls. There are now 2 compliance paths to follow. I don't think these are extremely important. I mean, the one is using and following the same prescriptive paths that we've been used to of the control requirements that we'll talk about. But they also provide a little bit of a carve out if you're using in a given space what they call luminaire level lighting control. And if you're familiar with that, actually there's a definition for it. The definition inside of the IECC is that it's a lighting system consisting of one or more luminaire that has embedded lighting control logic. So it's got some control ability inside of it. Most importantly is that it has the ability to detect occupancy and also can provide ambient light control for daylighting control, if you will. These are to be wireless, or at least have the capability for wireless communication, and then a local override where that is required. But and so the reason there's this carve out is just that luminaire level light controls already have some built-in controls. Like they already have a daylight sensor, and so the expectation is that sensor is always operational and changing the output of that light based on what it's seeing. And therefore, the carve out is that you don't have to follow per se the daylight responsive control requirements because that capability is already built in. And so that's really what this pathway does, is provide that clarification on how to apply luminaire level light controls. All right, let's take a look here at occupancy sensor. A change from 2015 is that the time delay that had been 30 minutes is now 20 minutes. And I think most of the default for manufacturers is already like 15 or 20 minutes anyway. So, I mean, out of the box, occupancy sensors are largely going to meet that. Then these are the required spaces when you that must use occupancy sensing for its automatic time shutoff control. When I went back to the 2015 to see what you were looking at, there have been a few spaces that were added to this list. Corridors is one on the last code cycle that was added. The other very significant one was the open plan offices, which we're going to talk to. But most of these other spaces, I think that you've already had that requirement inside your state. When an occupancy sensor is inside of a space, it can be utilized to automatically turn on the lights. When it does that, the code restricts that you can only turn on the lighting as much as 50% of its power. We're not to turn it on to full automatically, but there is a carve out. There are some exceptions. These are the spaces that are allowed to go to full on if you choose to use automatic on. The requirement here actually lets you make the choice. Do I want to use a manual switch and have the users manually turn the lights on, or automatic on? And if it's automatic, 50% is the maximum that's allowed. But these other spaces here where you're designing for, illumination levels that we expect to stay at 100% when people are present, these ones are allowed to go to full on. And one other thing that was added in these spaces, these tend to be more public spaces, is they now permit that no manual control has to be installed, where prior it was expected that manual controls were applied to the spaces. So these spaces both can go to full on, and also it's on. You don't need a manual control in that space, or there might be some kind of a safety or security risk. You're not required by the code to put it in. All right. There are three space types where when occupancy sensors are applied, they're applied differently than all the other spaces. Most other spaces, it's an on-off control. But in warehouses, the minimum requirement for application of occupancy sensors is that they are to reduce the lighting by at least 50% when no one is inside of an aisleway, or even if it's an open warehouse where they're just flat stacking inventory in those areas, that the lighting can automatically reduce by at least 50% within 20 minutes of there not being someone there. And you think about it, you've got these big aisleways, these picked aisles. You might not have somebody go down those aisles for quite a long period of time throughout the day. There's no reason to have those lights burning at full. Absolutely permissible to shut the lighting all the way off. Reducing the lighting by 100% is always more than 50 if that's a control strategy that you choose to use for that. So there's no real key exceptions to this. Another space is that has its own specific occupancy detection or occupancy sensor control requirements are open plan offices. This happened in the 2018 IECC, is that open plan offices are now required to use occupancy sensors for control in those spaces. And the zoning is limited to a maximum of 600 square feet per occupancy detection zone. I mean, if you take a look at this little diagram here, a simple open office space, chosen to divide it up into 3 different occupancy detection zones, all under 600 square feet. In this case, we're following the furniture plan to kind of decide what that looks like. What is different about the open office, besides just lights being able to turn on by detection and off by detection, is that it does allow you to reduce the lighting to 20%. You don't have to go to full off. You can go to a courtesy level. So if you don't want areas where you might have lights on at full, or maybe some other dimmed level, and adjoining spaces completely off, the code gives this allowance for a 20% courtesy. So if an adjacent zone is occupied, that all the other zones themselves are not occupied, they can sit at 20% lighting output. But eventually those have to be able to turn all the way off when no one is inside that space. There is a exception to that. This is also showing the overlay of a primary and secondary lighting zone here with these dotted lines. But there's also an exception provision that allows the overall shutoff to be time switch controlled. That's for the purpose that you may also, just like if you may have people in adjacent 600 square foot spaces that are individual occupancy detection zones that may be staying there, and you don't want the other zones to go to full off. You may have people in perimeter offices or in perimeter spaces that you don't want that lighting to go full off too. So it does give you the ability to use a time switch to get your full off. It doesn't negate the fact that you still have to provide 600 square foot areas of control by occupancy sensing detection that at least turns the light down to 20%. Many spaces, the most simplistic way to handle this is just to allow it to shut the lights all the way off. But that may not be what is desirable by your building owner, or maybe the way that that space needs to be designed. So you got that 20% that you can have if there's any occupancy throughout anywhere in that whole open office. Okay, the next space, this is the last one that has specific occupancy detection requirements, and that is for corridors. This was added in the 2021 IECC. It has been in ASHRAE for a very long time. And similar to warehouses, at corridors, if no one is occupying those spaces, and with a timeout delay of 20 minutes or beyond that, that the lighting has to uniformly reduce by at least 50% lighting power. So lighting can remain on at a certain level when the building's occupied, but if that particular corridor is not occupied, that it would sit at a lower level so that we're not using all that energy. There is one exception to that, and that is just if the corridor lighting is less than a 2-foot candle, which is not all that common, but you may have some exit and egress spaces of corridors that may have a very low illumination level, that this requirement wouldn't apply, obviously, because if you go to 50% power when you've only got 2-foot candles, we're going to be below what is the required minimum for illumination for egress. All right, if you're not doing occupancy sensor control in either the required spaces or other spaces that may not have that specific requirement, you must provide some other method to shut lights off. Time switch control is what has been used for many years in order to accomplish that. Same requirements apply, that you've got to provide an override that only allows you to override up to 2 hours. And there is a 5,000 square foot control area limitation for that override. So you can't turn the whole building on for one person coming in. There are some larger spaces that allow that 2-hour override to be use a captive key switch device so that there is no time duration to it, and that they can control all spaces larger than 500 or zones larger than 5,000 square feet. There are some basic key exceptions here, and I think those we're probably fairly familiar with those. I'll keep moving. We got a lot to cover here. There is a light reduction control requirement, and that is that we provide manual control of the general lighting. This applies to the general lighting, so that that lighting can be reduced by at least 50% by the occupant if they don't want full lighting. It can be done with continuous dimming, but there has to be some intermediate step in addition to the full on and off that has to be provided by the manual control. Now, this only applies to spaces that are using time switch shutoff. It does not apply to spaces that have occupancy sensing shutoff. It's just a way that if you're using time-based control, that there can be additional efficiency gained and adjustability of lighting by the occupants inside those spaces. There's a pretty good list here of key exceptions. It really has to do with what's the wattage or the LPD in the space. You can see there are a few spaces also that are excluded from this requirement. Manual controls, I think we're fairly familiar with that. We've got to provide that. They have to be accessible. Or if we install them remotely, right, you've got to identify what lights are being controlled and indicate what the status of those lights are, so that people, when they go use a remote switch station or location, they know if they're actually turning lights on or off that they can't visually see. Okay, one of the biggest changes comes along with daylight responsive control. So in the past, you've had a requirement that any side lighting that's coming in through a vertical fenestration or a window, that you have a singular daylight zone, if you will, that inside of a space that you're required to control the lighting to allow it to dim or reduce based on contribution of the ambient light or daylight from the outside coming into the space. And so what changed with this is that we no longer have a single primary zone. We actually have an adjacent secondary zone. These two zones need to be controlled independently, because the further you're in, the less that you're actually able to dim the lights and maintain the task level that you've designed. So those systems have to operate independently. There are systems that allow you to do that with a singular photocell, usually, and I recommend it be an open loop system if you're trying to use a single photocell. That way, the photosensor is not being influenced by the adjacent zone and what's happening there. But that is the requirement, and it used to have 4 spaces that required it to be continuous dimming. Well, now it applies to all spaces have to provide continuous dimming. There's no more step control that's allowed by the energy efficiency code. And additionally, I want to make sure you understand this only applies to the general lighting in the space, right? That's your uniform base illumination. So if you have other decorative or other type of lighting in that space, the daylight responsive controls are not required to be used for those type of lights. The trigger, and this did not change, is that you trigger a primary daylit, side lit zone and top lit zone when you have 150 watts or more of general lighting in that specific daylight area. And you trigger the secondary zone when you have 300 watts combined between the primary and secondary zone. There were some dimensional changes to the side light daylight zones. This was really to take IECC and match it up with the ASHRAE 90.1 standard and also with California, so that all the codes, that we're not driving lighting designers and engineers crazy that we've got different ways to calculate daylight zones. But in 2021, it all became the same and how that's determined. This shows from a side light daylight area what are some of the key exceptions here. One that was added as a key exception is when you have a shading system, or architecturally called a projection factor, outside the window, right? Because it was unclear what do I do if I've got a shade over a window? I don't have that same contribution of daylight that can come in with it. When do I and when don't I have to comply with this requirement to have automatic daylight responsive controls? So there's a little diagram inside the code that you'll see, a little calculation that you'll do based on how far that projection factor is, and then it will tell you based on if this is a north exposure or if it's a southeast-west exposure, what that ratio is for the exception to apply. One thing to be mindful of, though, is that if there's any fenestration that's above that projection factor, and I see this most common in a hotel. I'm actually in a hotel room right now, and if I hope that the Wi-Fi is good. If I get garbly, I apologize. You can blame Marriott for that. But usually, if you think about the carport that's on the entrance, oftentimes that projects out and all the cars come underneath that is usually attached to a lobby, and oftentimes that carport, there's windows above that. So just the fact that there's windows above that doesn't allow you to utilize this exception. They don't consider that carport a projection factor that's going to influence the daylight if you've got fenestration or windows above that projection factor. Okay. Trying not to spend too much time on this one. What this is a simple diagram of the primary and now the secondary side light zones and how that's determined. right? You have your exterior windows here. This is your primary. Your depth is based on the head height of the window. That's measurement from the floor to the top. And then there are 3 dimensions. This is what changed inside the standard. Besides adding the secondary side light zone is a little nuance to how we determine the width of a side lit daylight area, right? Certainly it's the sum of the windows, but the big change here is that instead of it being 2 feet on each side, it is now 1/2 of the head height. So the head height of the window is the primary dimension that helps us determine the size of that zone, both how far to come in and then how much to extend. So if it's 8 foot from the top of the window to the bottom of the floor, you're going to add not the 2 feet that we used to. It's now would be, in this case, in that example of an 8-foot head height, it would be 4 feet on each side. And that same head height dimension is also utilized to determine when that daylight zone has a break in it. Now, I want to tell you that your wattage that you're trying to calculate, am I achieving 150 watts or 300 watts of general lighting? That the wattage doesn't break up. It still sums across the zones in an individual space. However, what if there is a sufficient break here, the main thing is that we don't want a dark spot. And so essentially you have to then, that just tells you that you've not got to provide non-responsive lighting in that space so we don't make it overly dark for people in those areas. So there's some nuances to the lighting design in order to handle it if you have large breaks between the windows themselves that establish your side light zones. Okay. All right. Top lighting, that's just lighting that's coming down from above through a skylight or some kind of a fenestration up above. That has not changed. It's still only a single primary top light, daylight zone. The dimensions to how you determine that have not changed either, right? It's 70%, if you will, of the distance of the ceiling height in all cardinal directions from the footprint of that skylight. So there was some further clarification that was added for daylighting in a top light area for atriums, multi-level atriums. There was some confusion as to what you need to do on their intermediate floors. Like, do I still have to apply that 0.7 times the ceiling height? And how do I do it when I've got this atrium? Well, the code now clarifies that only applies to the very top floor in a multi-level atrium, that you have to use that 0.7 times the ceiling height, and that ceiling height is, again, measured from the floor to the top of the ceiling. And it applies, that's where the daylight responsive controls have to be applied, and also on the floor area directly under your roof fenestration assembly or skylight. But the intermediate floors do not have to have daylight responsive controls. All right. There is an exemption to daylight responsive controls if you reduce your overall lighting power in the building. There's a calculation for that. We're not going to walk through that, but you can trade off maybe individual zones or maybe the whole building by reducing overall your lighting power inside the building. That's the main control requirements, largely affecting all of the general lighting. Let's talk about any special application lighting or non-general lighting, right? That's your lighting for display and accent cases, under shelf, under cabinet lighting, and some other lighting. Main requirement for this lighting is, number one, is that you do have to provide a separate manual control from the general lighting. So if you have wall sconces or some kind of decorative lighting that is not considered and utilized as providing your uniform illumination throughout the space, that what you need to do is be able to provide a separate manual control so that it can be shut off independent of the general lighting in the space. The other thing is that this lighting still has to have automatic off control. It's not exempt from the automatic off control requirements, but you get to decide, am I going to use occupancy sensing or time-based control in order to do it? The code doesn't dictate it that it fall within one or the other, even if it's inside of a space that may require occupancy sensing control. always like to suggest that, if you are using occupancy sensing control for your general lighting, that same sensor can be used and its control can be used to shut off your decorative and accent lighting as well. It makes it simple. It doesn't make it confusing, and it's simple for design. And same thing goes if you're doing time-based control. Just shut it all off based on time if you're already doing that for that given space. Also under the special application section, and this is the question earlier about hotel guest rooms, is that, and this has, I think, been in the 2015 IECC that you're under, is just that lighting needs to automatically, and the switched receptacles are to shut off within 20 minutes of an occupant leaving. So I don't think that's really a big change. There is an exception in that if you use a card key switch. You've seen those in some hotels. You see it when you travel through Europe. This is what they use. If you don't put a card key in there, then like nothing in the room works. You don't get heating, you don't get cooling, you don't get lighting. So if you utilize that, then you don't have to do the automatic shut off. Some basic requirements for lighting that's considered non-visual. That's for food warming and plant growth like that. There's not a manual control requirement, but there is a time switch shut-off control so those lights don't get left on indefinitely. And also some requirements to provide a manual control only, no automatic shut-off required for your medical task and dental task lighting. There's got to be a way to shut it off. Okay, we're moving outside, not outside the building quite yet, but we're going into parking garages. A lot of new requirements here in the parking garage area that you have not seen before and have not been part of the IECC. And it actually made it kind of ambiguous how to apply things because the interior lighting controls just didn't seem to apply well to a garage anyways. So this helped to clarify a lot of that. First is that all that lighting must be able to automatically shut it off, whether it's by time switch or an occupancy sensor. It doesn't dictate which technology you decide to use or how to go about it. Remember that your top deck is exterior. If you've got a rooftop parking, that falls under exterior control and is not part of these requirements. So first requirement is shut off all the lighting. You have to provide that capability. Additionally, that it kind of like the warehouse in the corridor, it has a requirement to reduce the lighting by at least, in this case, it doesn't say 50, it's by 30%, because back when this was written, I think there were still some HID lighting that couldn't go all the way down to 50%. Most of the other codes and standards have already moved to what LED can do to that 50%, but in this case, it is you must be able to reduce the lighting power by at least 30% when there's no activity detected. And so that means you're using occupancy sensors. And those of you who have more recently designed and applied fixtures inside of a garage know that there's a plethora of manufacturers out there that provide fixtures that have integrated occupancy sensing detection specifically for this purpose inside parking garages. There is a limitation to how big a space, but boy, most of the applications I see, they do it on a fixture by fixture basis anyways. The only exception to this is if you've got less than 1.5 foot candles at the darkest spot inside your parking garage. So that way, again, a 30% reduction wouldn't take you below the 1 foot candle level. It's needed for illumination for safety and egress. All right. Another requirement in parking garages is controllability of lighting in a daylight transition zone. So if you have and you've designed lighting for that eye adaptation from coming from the bright outside into the much reduced light level inside of a garage, or vice versa, going from a dark garage out into traffic where you may have full daylight going on out there. There are IES standards for how you illuminate those spaces so that the eyes can adapt. If you have that adaptive lighting inside the parking garage, that lighting must reduce by at least 30% from sunset to sunrise. It's kind of the opposite of what we're doing on exterior lighting, but the intent behind that is that we don't need all that lighting in the evening. There's no eye adaptation that needs necessarily to happen. And so this is the code is just making sure that lighting gets reduced between those dark hours. Okay, the last requirement for parking garage lighting in terms of controls is that within 20 feet of the perimeter wall opening is that you have to provide some automatic reduction of lighting when you have adequate daylight. This is a little bit different than the indoor because it only says it's within 20 feet. It's not trying to prescribe, daylight zones per se. And also, this does not have to be continuous dimming. You can just do it by a simple 50% reduction when it's deemed that there's enough and there's adequate ambient light coming in. Are some exceptions. Probably your biggest one is going to be that the wall ratio. If you don't have enough opening, right? They say a 40%. If it's below 40% of a wall opening ratio, then you're not required. Also, if there's blocking obstructions, and also if there is architectural screening or architectural things that will cover up the contribution of that light. All right, that's it for our interior controls. I thought it might be good just to take a look at what has changed with LPDs. So this is looking at building area method for 4 buildings that I've chosen: office, retail, school, and warehouse. I believe this is where you are under the 2015 IECC and the 2018 North Carolina State Building Code for watts per square foot. And this is what we're moving to in the 2021 IECC. ASHRAE and IECC share the exact same tables for lighting power. They actually come out of ASHRAE. So this actually, the 2021 is, and this big shift here is the change essentially from fluorescent moving over to all LED. The 2021 IECC is now on all LED baseline. So this is going to be a little bit tougher than it has been for you. LEDs have certainly moved way beyond where the 2015 IECC was. Real easy probably for you now to comply with LPD. You don't have to worry about that so much because we have these efficient LEDs. But when this comes online, I think you will have to be a little bit more careful to make sure that we're meeting those requirements. In the exterior, and I picked looking at just zone 3, the base side allowance from the 2015 to the 2021 change, we lost 250 watts. And also notice that, and I just took, there's, many different areas where there is an LPD. I just picked the parking and drive, a very common one. Here is, it's changed from 1 to 0.06. You know what? Bob, you're asking me a question about what's the overall percent reduction average requirement for NC from. I don't know the answer to that. I mean, I know these tables have been changing dramatically during the code. These last 2 code cycles leading up to the 2021, and you can see the significance. I mean, look at retail, right? Significant jump. And and even to try to average it based on all the space types that are sitting there, it gets a little bit hard to do that. I think somebody at the National Lab does do that, but I don't know. I've got a comparison for you from the 2015. So, all right, exterior lighting controls, right? Same one that we know we got to shut off that exterior lighting whenever there's daylight outside. There was an exception put in for dwelling units. This is probably more important now that we have dwelling units inside this, the requirements, and that is that if you've got a switch operating, some lighting that's controlled from within the dwelling unit that's on the exterior, that's exempt, if you will, from that shut off when there's adequate daylight. Our facade and landscape lighting, you've already seen this, I think. It's in the 2015. This lighting is not for our visual acuity and safety and security. This is so we can enjoy the grounds around the building and the architecture of the building. That lighting is required to shut off no later than 1 hour after business closing to 1 hour, and then can come and and stay on up until 1 hour before business opening. At least that's what the code says for that lighting. So that's the full shutoff on the exterior. The other lighting has to do some kind of a setback. It's got to be at least 50%. If we don't establish what the business hours are, the code requires it to be midnight to 6 a.m. You've got to reduce that lighting by at least 50% lighting power. So that 50% is an adjustment. It used to be 30, but now that LEDs can easily go down to 50, it's now established at 50. And that applies to all other lighting, except for some cases in parking lots. And so what is different in parking lots is that if you have fixtures that are mounted at 24 feet or less, and the fixture wattage is over 78 watts, which is pretty easy to be under 78 watts, actually. In those cases, it requires you to use occupancy sensors, detect if there's activity, and reduce the lighting by 50% when there's no activity. So this only applies to parking lot areas. It doesn't apply to all exterior spaces. And it's just to reduce that lighting, based on occupancy. But it only applies again at when your mounting height is 24 feet or less, and you've got a fixture that is greater than 78 watts. It's trying to harvest some more energy efficiency by using occupancy detection or motion detection. Sometimes they say in the outdoor, you say motion in because you're not really detecting occupancy. But all right. Yeah, there's no exceptions to that. Okay, the last and main area, well, actually, I guess there's a couple of others, this is a big one. It's been an ASHRAE for a very long time, since 2010. And this is this is more power, and that is the plug load control that is technically called automatic receptacle control, right? We have certain space types. This is the list of those space types where 50% of the receptacles, when we say 50%, this is a duplex outlet. It actually has two receptacles in it. So you can control the top, and actually in the standard, it is that the top one needs to be controlled, and the bottom one would be the uncontrolled if you are controlling it in a duplex format. But uniformly throughout a space, in these space types, and also when you have individual workstations, this largely is applicable to an open office. You think about all the receptacles and plugs that are inside furnitures, you have to be able to reduce the lighting, or you have to be able to shut off at least 50% of the receptacles. Thinking back on lighting, sorry about that. So you can do it by time base, you can do it by connecting or turning it off with an occupancy sensor that's already doing that for lighting. That's probably the most advised and cheapest way to get it done. It also says you can do it with some automated signal from another system, like a billing management system. So there are a few little requirements around that. We know that NEC already has permanent marking requirements for marking requirements on receptacles that are controlled. All right, there's a question here about going back to the 78 watts for parking lots. Is that per pole or per luminaire? That is a per luminaire requirement. So, and then there's also energy monitoring requirements. Essentially, you have to provide a system in buildings that are 25,000 square feet or greater that can monitor separately the HVAC system power, interior lighting, exterior power, plug load, process loads, and then other miscellaneous loads inside of a building. Those you have to have a system that does that and can do it on at least a 15-minute basis and maintain the history over 36 months so that you can look backward at the trends and see if something's going awry with your efficiency. So those are the two big electrical requirements: automatic receptacle control, plug load control, and then this electrical energy monitoring. But the electrical energy monitoring only kicks in buildings that are 25,000 square feet or larger. All right, we're getting close here. We have the additional efficiency requirements. I believe you had that in the 2015. And inside the 2021, they added some credits or they added some additional options for you to follow, but they also changed the format of how the additional efficiency requirements are met. There are only really two requirements in here, or optional requirements, I should say, or efficiency options that are lighting related. One is to reduce your lighting power, and the other one is to use what they call enhanced lighting controls. That's like almost like putting LLLC throughout the whole building. Not used very commonly. Usually the reduced lighting power is the one that we see used the most. When does it apply, and how does it apply? Well, instead of, it used to be that you could just pick one of these options, and if you applied that option, you were good to go and you were compliant. Now you have to meet a number of credits, have to receive 10 credits. So you might have to do multiple of these in order to reach the 10 credits. I'll show those to you. Tenant spaces have to get 5 credits, and then there is an exception if the tenant space already, had complied before, that it's not necessary to now. So what do we have to do on the lighting side if we want to utilize that, the reduction of lighting power to meet the additional efficiency requirements? Well, we've got to reduce the lighting power from our base building load that or allowance that's given to us by at least 10%. And you can actually earn additional credit points if you go as far as or above 15, if you will. In a dwelling unit, there's not really a lighting power because it's an efficacy requirement. It simply just changes that efficacy to not apply to 90, but 95% of all installed lighting. So a 5% tick up increase. So how do you figure out what credits you get? Well, if you take a look at this table here, and there's a bunch of these tables for different building types. I'm only looking at the group B for business or office building. They have one for education and for retail and for others. So you got to look at the right table. And then you also have to know your climate zone, right? So inside of North Carolina, you guys spread across 3 climate zones. Your primary climate zone is climate zone 3A that starts from the Atlantic and goes through most of goes through all of the eastern and actually central part of your state. You have a few areas and a band that is a 4A climate zone, and then just a couple of counties. I think they're up in the northwest. I think you must have some elevation there that are considered cooler, that are in that 5A band. But if you reduce your lighting power by 10%, this is the number of credits that you can achieve. 9 credits in 3A, 8 credits in 4A, and 7 credits in 5A. So by climate zone determines how many credits you can receive by applying that. Now, if you go to 15%, it actually, you get another 50%. So if you're in climate zone 4A and you're getting 8 credits here for reducing your lighting power, you actually can receive 12 credits if you get to 15% lighting power reduction. So it's not all us. Other HVAC, there you can get some credits. Putting renewable energy on, there's other ways to do it. But it's, for some reason, it just seems like they tend to pick on the lighting guys. They pick on us in order to provide this provision. All right, we're almost to wrap. Functional testing, that's the requirement that you have to be able to get some kind of, before final inspection, right? We have to provide some kind of evidence that your occupancy sensors, your time switch, and your daylight responsive controls have been checked, and so that they are functionally tested. This is important because those same controls that go in a building can waste energy if they're not operating correctly. And therefore, this gives proof that they not only were installed, but that they're operating correctly. All right, I am going to skip the summary because this change summary only applies from the 2018 to the 2021. It's bigger for you because you're skipping a code, and I'm going to talk to, just for a second, compliance help. Hopefully you can utilize that quick guide and share that around. I'll maybe at the end of this, I'll mention where you can get more quick guides for other codes. But when I said that the 2024 North Carolina State Building Code is available, it is available online through IECC. Here actually is a QR code if you want to grab that. That will take you directly to a free view They call it the basic view, I think, but there's a free view version of the North Carolina Energy Conservation Code for 2024 that is available and online right now. So that's where you can go get that. Pause to make sure that you can grab that QR code. Or I mean, you can probably just easily just do a search for 2024 North Carolina State Building Code. Maybe put ICC on there. The International Code Council is the one who publishes it, and it should get you close to here or right to this page anyways. Okay. Okay. So that is the wrap on my end for the requirements. I hope that was helpful. What I want to tell you, and maybe I should have put a QR code here, but I work for Legrand. A watt stopper is our main lighting control line. But if you search on Legrand Code or Legrand Code Solutions, it will take you to our code webpage. And at that webpage, you can download the quick guide for 2021 IECC. You can download the quick guide for the 2019 ASHRAE IES 90.1. And many other codes if you happen to be doing work in other places. You can also see a list of the states and what code quick guides would apply to it. Essentially kind of shows you what code that they're currently on. We keep that up to date. And so it's a great place to get resources, also some help for code compliance you can find there for your designs. So let's see, we do have a question here. Is the following statement correct? For mounting height 24 feet and less and luminaires less than the 78 watt input or less, you must have both 50% dim luminaire capability and motion control. It applies when you're greater than 78 watts. Okay. So it's only when the wattage is above 78. Yes, 24 feet or less and above 78 watts, you must provide dim capability. It says, and motion control. Well, the motion control triggers the dim capability is what it does. So yes, when we say dim, it just has to be able to drop its light level. So, I mean, we could say that that's dimming. And it says here, does this apply to NEC and SEC utility leased lights? You know what? Jurisdictions will make decisions on what they have to comply with. So oftentimes, if they're regulated or handled by the utility, it's up to the jurisdiction to decide what requirements they are. So I don't know specifically if the municipality lighting that's handled by, typically by the utilities or by the municipality, if they will follow that or not. It's usually they're typically not even pulling permits, I don't think, to do that work. So they're probably not overseen by the building officials in the building department. But I don't know the good answer to that. So, or direct answer, yes or no. Hey, thanks for joining us today. I don't know, Greg, any wrap up?
Yeah, well, thank you, Harold. That was an excellent presentation. Very informative and helpful. Yeah, it looks like we've answered most of the questions. I did see one about where can we find the overview document that you mentioned. I know you posted that in the chat early on, but I'm not sure if you may be able to post that again for anybody that joined a bit later. We can also email that as well.
Yeah, maybe, I'm supposed to get, I think, the list of those attendees with your email addresses. We can just attach it to that. And if it's okay, I'll put a link to our Code Solutions website. But the idea is get you the certificate. And so we'll look forward to seeing that.
Absolutely. Yeah. So we appreciate your time today and excellent presentation. I've dropped a few links in the chat there with links to find the recording. And we look forward to seeing you at the next presentations. So thank you again, Harold. This was great.
All right. Thank you.
Thanks, everyone. Have a great day.